This is a one mark question asked in GATE 2017 of electronics in set 1. This is from signal subjects and from the classification of system topic. The given question is, consider a single input, single output discrete time system with xn as input and yn as output, where the two are related as the equation given. Which one of the following statement is true about the system? So if you see the option, so we are interested to find regarding the causality and the stability. So we are given with these equations. We want to find this causality and stability of the system. So how do you do this? So to do this, what I can tell is, so this is one, the equation is given and where y of n is outputs and x of n is inputs, right? So here if you see, so actually the way the information is given, so for certain range of n, like from 0 to 10 we have some things, and for other range we have something else, right? So let's speak regarding the causality. So what is causality definitions? The definition is the system output, the present output should depend only on the present and past informations. There should not be any future dependencies, right? So because the information is for two different ranges of n, so we'll also make the analysis for different ranges of n. So what is going to happen when this n takes the values between 0 to 10, and what is going to happen when n is taking the values greater than or equals to 11, right? Or I mean other than this range, so what is going to happen, right, for other range of n. So I mean speaking about this one. So in this case, so y of n is equals to n into mod of x of n, and in this case when the n is not in this range, so I have written here greater than or equals to 10 because I have taken only the positive side, because so other than n means it is also taking the limits from -1 to -infinite as well. So let's not write greater than or equals to 11, so that will indicate only for positive value of n, so that's not the case. So other than this range means from -infinite to +infinite except this all value of n, right? So other than that, so we are expecting that y of n should be equals to x of n minus of x of n minus 1. So if you see, if I ask you what is y of 5, then this is n into mod x of 5. So if I ask you what is y of -100, then this is n into mod of x of -100. So what is basically happening is, the output at any value of n is dependent on input of that value of n. So if you need at 5, you also need x at 5. If you need at -100, you also need at -100. So if you need at n, you also need x at the same n itself. So what is happening is, in these cases, the present output is depending on present inputs. So that is a perfect case of causality. So in this range of n, this is causal in nature. Hope this is clear, because if this could have been y of n equals to n into mod of x of n plus 1, suppose instead of n it would have been n plus 1, then if I substitute y 0, you get x of 1. If I substitute y 2, you get x of 3. So in that case, present output depending on future information of inputs. But in this case, because of yn and x of n the way they have given, so whatever the value of n I am expecting the outputs, so it is dependent only on that particular value of n of the inputs. So this is perfectly causal case. What about this? If you see this, so this is x of n. So this is again a present dependency, and x of n minus 1. So this will indicate the past dependency. For examples, if I ask you what is y of 2, so this will be x of 2 minus of x of 1. So what is happening? Output at n equals to 2 is dependent on input at 2 and 1, right? So if this is the, like n axis. So this is n equals to 0, this is n equals to 1, this is n equals to 2. So your output at 2 is dependent on input information at what? 2 and 1, right? So output at 2 depend on 2 and 1. So this is not going towards future, it is going on present and past. So there is again no future dependency. If you take some negative value y of -5, then this is x of -5 and minus x of -6. So to find the output at -5, you need the input at -5 and -6. So with respect to 5, -5 is present and -6 is past. So in this range of n also, so this is causal. So for all value of n, what is happening is the output is dependent on present and past informations. So this overall system is causal in nature. So first thing is confirmed, this is causal. Next I have to comment regarding stability. Hope this is clear. For all range of n, so for all n, okay, so yn depends on present and past of x of n, not future. So this implies this is a causal system, right? So for all value of n in yn, depends on present and past of x of n, not on future value of x of n. So this implies this is a causal system. So now let's speak regarding stability. Again, for stability, I'll be again analyzing this case on two different ranges of n. So again, the first case is what is going to happen if n is between 0 to 10, and what is going to happen the other range of n, which is this one. So in this case, again my y of n is given, it is n into mod of x of n, and in this case again my y of n is given as x of n minus x of n minus 1. So in this case, if you see, so stability we are interested. So when a system is said to be stable, a system is said to be stable if each and every bounded input produces a bounded outputs. In other words, no bounded input should produce unbounded output. Then it is said to be a stable systems. So what is bounded input then? So a input is bounded, a signal is said to be bounded if its amplitude is finite for the entire range of time or for entire range of n. Then it is said to be a bounded signal or bounded inputs. So in this case, if you see, so between 0 to 10, okay, so this is n into x of n. So it makes sense. If I am telling x of n is bounded, okay, if I am telling x of n is bounded, so what does it mean bounded? So x of n is finite. So I am telling that x of n is finite in this range. So it makes sense. If this x of n is finite and n is varying between 0 to 10, now don't you think this y of n is also finite for this range of n? Y of n is finite for between this n equals to 0 to 10. This is obvious, right? Why? Because if I am asking you what is y of 1, so 1 into mod x of 1. I am telling this x of n is finite in this entire range of n. So this is finite and this is finite and this n is also finite because n is varying between 0 to 10. So this is finite and this is finite. So product of two finite quantities again finite. So in this range, this system is satisfying the condition of stability. So in this range, this is stable. Now let us also comment what is happening in this range. So in this case, y of n equals to x of n minus x of n minus 1. So what do you think? So is this operations is going to make any difference? Is it going to lead that y of n will be unbound natures? Obviously not. Why? Because x of n, we are subtracting its delayed version, right? So what is x of n minus 1? X of n minus 1 is the delayed version of x of n, and we are subtracting this quantity from here. So if you have a bounded signal and if you again subtract the delayed versions, so absolutely it is impossible, like the difference will be some unbounded quantity. So this is something like, so this is a finite quantity, okay, and if this is finite quantity, why finite quantity? Because we said x of n has to be bounded, so this is finite. And obviously if a quantity, its amplitude is finite for all value of n, if I am delaying it by 1, so this will also be finite. So amplitude wise if I see, so this is finite for all range of n and this is also finite for all range of n. And if I am subtracting a finite quantity from other finite quantity, again this answer will be finite. It can be 0, depends on situations, but one thing is confirming both of them are finite, then this answer is never going to be infinite. So this will be again finite only. So it makes sense, again if the input is bounded, so the output is again coming bounded the way it was happening in that case. So in this range also this is stable. So for all range, the system is satisfying the stability condition. So what I can say, for all range of n, for each bounded inputs, output is bounded, right? Output is bounded. So this implies this is a stable system. So for all range of n, this is causal, and for all range of n, this is stable as well. So the answer is this is causal and stable, and that is given in one of the options. So this set of problems are kind of, you just kill in a intelligent way, right? There is no straightforward approach. You have to see the equation and you have to think what are the other possibilities. So because I have explained, I have taken around 8-9 minutes of time, but if you solve in a proper flow, so this problem is hardly 20 to 30 seconds. So because in the theory classes, lot of problem you might have practiced and there are certain observations. If you get in that model directly, you can tick the options without much thinking about it. So that's the right answer for these questions. This is a 2-mark question asked in GATE 2017 of Set 1 Electronics. This is from Signal Subjects and from the LTA system topic. The given question is, two discrete time signal x of n and h of n are both non-zero only for n equal to 0, 1 and 2 and are 0 otherwise. It is given that x of 0 equals to 1, x of 1 is 2, x of 2 is 1 and h of 0 is 1. Let yn be the linear convolution of x of n and h of n. Given that y of 1 equal to 3 and y of 2 equals to 4, The value of the expression 10 into y3 plus y4 is dash. Okay. So these are the fact given. So x of n and h of n are non-zero for n equal to 0 and 2 and it is 0 otherwise. And x of 0 information we have and h of 0 is given and y of n is linear convolution of x of n with h of n. Actually convolution are of two types, linear and circular. So linear convolution is the general convolution what we speak. So that's nothing new here. And y of 1 sample is 3, y of 2 sample is 4. So we are supposed to find these expressions. So here the fact that you should be knowing is, suppose x of n has m number of sample, okay, and or let's say it is k1 number of samples, and h of n, let's say it is having k2 number of samples, then x of n convolution with h of n will have k1 plus k2 minus 1 number of samples. Okay, it will have k1 plus k2 minus 1 number of samples. So here if you see x of n and h of n are non-zero for n equal to 0, 1, 2. So what does it mean? So x of n and h of n having 3 samples. So those are at n equal to 0, 1 and 2. So it means k1 value is 3, k2 value is 3. Then it makes sense y of n, so it will have how many samples? 3 plus 3 minus 1, so that is 6 minus 1, that is 5 number of samples. So we should be very clear that y of n having 5 number of samples, x of n having 3, h of n having 3, then y of n will have 5 number of samples. So if I write it, this x of n, so it is having 3 samples, 1, 2 and 2. So 1, 2 and 2. Right, so this is how it is given, and if you see this 1, 2 and 1, right, 1, 2 and 1 actually, sorry, make a change here. So this is given 1, 2 and 1, right. So this is also 1, sorry. So this was actually given 1, I have written 2, so make it 1. This is given in the question, okay. And h of n, okay, if you see this, so this h of n, its 0 sample is given 1. So but how many sample it is having? It is having 3 samples. So these 2 sample we don't know. So let's say these 2 samples are A and B. So h of 0 is here, so the arrow mark is here. Similarly, your y of n, so y of n having how many samples? So it will have 5 samples. Out of 5 samples, y of 1 is given 3 and y of 2 is given 4. So what is y of 0 then? Let's take y of 0 is C. And y of 1 is given 3, y of 2 is given 4, and the other 2 samples like y3 and y4, let's take it is D and E, because I know it is having 5 number of samples. So out of 5 samples, the first sample and second sample are given 3 and 4. So 0th sample I have let it to be C, and the 4th and 5th sample I have let it to be D and E. So this is the case now. So how do we address this case now? So to address this case, okay, so it is also given that y of n is xn convolved with h of n. So what I can do then? So it will be 1, 2, 1, convolution with 1, a, b, okay. So I hope you know this method of convolutions, like by multiplication methods or the tabular method, whatever you can tell. 1 into 1 is 1, 1 into 2 is 2, and 1 into 1 is 1, a into 1 is a into 2 is 2a into 1 is again a, b into 1 is b, and this is 2b, and this is b, right. So this is the normal method to do the convolutions if you have finite number of samples, right. A to a, and then you have b to b and b. So this is what your 1, this is what your 2 plus a, this is what your 1 plus 2a plus b, this is what your a plus 2b, and this is what your b is. But what this is? So this is what your x of n was, this is what your h of n was, and this is what is your y of n is. So this is the case, okay, this is what your y of n is. And what is the 0th samples? So this is the 0th sample. How can I say the 0 samples? Because the lower limit of x of n is 0 and h of n is also 0. So y of n lower limit should also be 0, because sum of lower limit is lower limit of this y of n. I mean lower limit of this plus lower limit of this is lower limit of yn. upper limit of this plus upper limit of this also upper limit of this. I mean to say if this is at n equal to this at n equal to 0, so the first sample must be at n equal to 0. Similarly, if this is at n equal to 2 and this at n equal to 2, then the last sample should be 2 plus 2, 4. If I take this is 0, 1, 2, 3, 4. That's perfect. So this is what y of n expression I am getting, and y of n is, I have written it like this. So y of n is c, then 3, because the 0th sample I have taken it is c. Next sample y of 1 was 3, y of 2 is 4, y of 3 is d, and this is e is, y of 4 is e, right? C34D, C34D. So by comparisons, so directly I can tell c is equals to 1, then I have these equations, 2 plus a equals to 3, so your a equals to 1. Then what else you need? So we need a, b, c, d, e, right? So I have used a, b, c, d, e. So a I got, c I got. Then here I can get from in these equations I can get b. So what is the equation? 1 plus 2a plus b is equals to 4. So a is 1 I got, right? So 1 plus 2 plus b is equals to 4. So b is equals to 4 minus 3, that is coming 1. 1 plus 2a plus b plus 4. 1 plus 2a plus b is equals to 4. So a I already got 1. If I substitute here, 1 plus 2 plus b equals to 4. So b is equals to 4 minus 3, that is 1. I got a, I got c, I got b. Then I can get d also. What is d? D is my a plus 2b. So a I got 1 and b also I am getting it is 1. So 2 into 1 is 2. So that means d is equals to 3. And finally if you need e, so b is equals to e. So e is equals to b and b is 1, so e equals to 1. So basically your h of n, which was a, b, so it is 1, 1, right? So this is nothing but equals to 1, 1 and 1. Similarly, y of n, which was c, c value I got 1, then I have 3, I have 4, then I got d value is 3 and e value I got it is 1. So this is what my y of n. But anyway, finding a and b are not my priority, because to answer this y3 and y4 I need. So this is y of 0, 1, 2, 3 and 4. So this is my y3 and this is my y4. So this is my y3 and this is my y4. So y3 is equals to 3, y4 is equals to 1. So this is 10 into y3 is 10 into 3 plus 1 is nothing but 30 plus 1. So that is coming as 31, right? So actually my target was to get this d and e, because in the questions I need y3 and y4, and y3 and y4 nothing but d and e. But to get e, you should know b. Similarly, okay, so if you know this a and b, you can get de. Okay, finding c was not needed, but anyway c was very straightforward. So the answer is 31. So this is again a very stepwise systematic questions. It's a easy questions. So again I have explained this, so I have taken around 7-8 minutes of time. But if you solve in a proper flow, so this is also hardly 1 minute job. The answer is 31 for this. This is a 1 mark question asked in GATE 2017 of electronics. This is from signal subject and from continuous time Fourier series topic. The given question is, a periodic signal x of t has trigonometric Fourier series expansions. If x of t equals to minus x of minus t is equals to minus x of t minus pi by omega naught, we can conclude that. So if you see all the options, basically the question is from the what is symmetry conditions, isn't it? So you have to comment regarding this coefficients a naught, an and bn. So for what value of n they will be 0 and what value of they are non-zero. So based on that they have jumbled all the options. Anyway, so when it is said that x of t is equals to minus x of minus t, so they are indicating that it's a odd signal. So x of t is a odd signal. This is the condition for odd signal. So x of t is a odd signal. And if it is a odd signal, you know very well the a naught equals to 0 and an equal to 0 for all n, right? If a signal is odd in nature, its even part is 0. If x of t is odd, then this even part will be completely 0. This is the even part, right? So a odd signal doesn't have even part and an even signal doesn't have odd part. So if x of t is odd signal, so its even components will be 0. So they become 0. So we'll be left with only this. So in this case, if x of t is odd, okay, so then this will be given by summation n equals to 1 to infinity. This is bn of sine n omega naught t, right? So I would have stopped here provided if this condition would not have been given. But now one more condition is given, that is x of t is equals to minus x of t minus pi by omega naught. Actually, you know very well, so this is equivalent to say this is minus x of t minus t by 2, because t is given by 2 pi by omega naught, right? So t by 2 would be pi by omega naught. So wherever I have this pi by omega naught, I have substituted here, it is t by 2. So this is the condition for half-wave symmetry. This is the condition for half-wave symmetry. And what happens in half-wave symmetry? What is the consequence of half-wave symmetry? If a signal is half-wave symmetric, it means its odd harmonic component will exist. Its odd harmonic component will exist. In other words, all even harmonic component will be absent. This is what the meaning is. So now, when I know it is a only odd signal, then I would have said that Bn exists for all value of n. But now, along with odd, if I am imposing one more condition, that is odd as well as half wave, then in this case what I should tell is this is n equals to 1 to infinity Bn sine of n omega naught t, but my condition is I should have only odd value of n. So here I am writing only odd, right? So if I expand it, it will have B1 sine of omega naught t plus B3 sine of 3 omega naught t plus B5 sine of 5 omega naught t, and so on and so forth. Okay, this is what is the trigonometric Fourier series expansion of x of t signal look like based on these conditions. So if you see all the options, which option is satisfying this? What criteria you have? Option A is telling an is are 0 for all n, bn are 0 for even n, an are 0 for all n. So an is 0 for all n? Yes, an is 0 for all n, and bn 0 for even n. So yes, bn is 0 for even n. So it seems A will be the right answer. Let's see the other options. Option B is telling an are 0 for all n, but bn are 0 for odd n. No, bn are non-zero for odd n. So option B is wrong. Option C is an are 0 for n even. So they are saying only for even n a are 0, but whereas an is 0 for all n. So option C is also wrong. Option D, an 0 for odd n, again they are telling this is selectively for certain value of n it is. So anyway, the answer of this will be A. An are 0 for all n and bn are 0 for even n. So bn exists. So from this what I can say is, so I can say here the Fourier series will contain only bn terms for odd n, only bn terms for odd n. This is what the final conclusions. And if this information is given in option A, and A is the right answer for these questions. This is a 2-mark question asked in GATE 2017 of Set 1 Electronics. This is from signal subjects and from continuous time Fourier series topic. The given question is, let x of t be a continuous time periodic signal with fundamental period t equals to 1 seconds. Let ak be the complex Fourier series coefficient of x of t, where k is integer valued. Consider the following statement about x of 3t. The statement 1 is telling the complex Fourier series coefficient of x of 3t are ak, where k is integer valued. Statement 2 is telling the complex Fourier series of x of 3t are 3ak, where k is integer valued. And the fundamental angular frequency of x of 3t is 6 pi, that is given in statement 3. So you have to identify which of these statements are true, right? So actually x of t is a continuous time periodic signal, its fundamental period is 1 seconds. ak is the complex Fourier series coefficient of x of t. Then we are supposed to comment regarding this x of 3t. Now this question is based on the scaling, time scaling property of continuous time Fourier series case, right? So which, like if you know the property straight away you can tick the answer. But anyway, you know very well x of t is given by sum of k from minus infinity to infinity, and this is ak e raised to power minus of jk omega naught t. So this is the general formats of any periodic signal. Its complex Fourier series representation look like this. Here the fundamental frequency is nothing but it is omega naught. Now let's say if I am asking you what is happening to x of alpha t. So that is what, if I am doing the time scaling, if I ask you what is happening to x of alpha t, then what you will do, if this is x of t, if I ask you what is x of alpha t, then wherever this t is there, you're replacing that t by alpha t. So this is ak, right? And because there is no t term here, then it is e raised to power minus of jk, and this is alpha omega naught into t. Because if I am replacing this t by alpha t, overall this function will be e raised to power minus jk alpha omega naught t. So I have written it like this. So here, if you see this, in this x of t representations, if I ask you what is the complex Fourier series coefficient, so whichever thing is multiplied with this exponential, complex exponential factor, that is what is your complex series Fourier coefficient. So whichever thing is multiplied, that this thing is multiplied with this complex exponential factors, so that is what your complex Fourier series coefficient. So here the complex Fourier series coefficient is ak. Okay, and similarly if I ask you what is complex Fourier series coefficient here in this case, whichever is multiplied with this exponential factor, that is again ak. So complex Fourier series coefficient of this is still ak. So the complex Fourier series coefficient of x of t was ak, and for this also this will be again ak. It is not 3ak, it is ak. Next is regarding the frequency. So here if you see, so this is what the frequency is, right? So in other words, e raised to power minus jkt, along with it whichever thing is multiplied, that is what nothing but my frequency. Here along with e raised to power minus jkt, omega naught is multiplied, so the fundamental frequency omega naught. Here with respect to e raised to power minus jkt, the multiplying factor is alpha omega naught. So in this case, obviously if somebody asks what is the fundamental frequency, so it will be definitely alpha omega naught. So x of 3t have complex Fourier series coefficient a of k, but its fundamental frequency will be 3 omega naught. It was alpha omega naught, alpha is 3 here, the scaling factor is 3, so this will be 3 omega naught. So coming to statement 1, complex Fourier series coefficient of x of 3t are ak. Yes, it is true. Statement 2, complex Fourier series coefficient of x of 3 are 3ak. This is wrong. Statement 3, fundamental angular frequency of x of 3t is 6 pi. Okay, by the way, its fundamental time period is given t naught equals to 1. So its fundamental frequency omega naught is given by 2 pi by t naught. T naught is 1 means this is 2 pi. So if omega naught is 2 pi, then 3 omega naught will be 6 pi, right? So fundamental angular frequency of x of 3t is 6 pi radian per second. This is also true. So statement 1 and statement 3 are true, and statement 2 is wrong. So this is given in option B. So B is the right answer for this. So this is actually a standard information based questions. Even you don't know this, if you know the property, directly you can answer it. So answer is option B for this. This question is asked in GATE 2017 of Set 1 Electronics. This is from Signal Subjects and from Laplace Transform topic. The given question is, consider the following statement for continuous time LTA systems. Which one among the following is correct? So two statements they have given. I have written those statements in board. Let us make analysis and comment which of them is correct. Okay. So first statement is telling there is no bounded input, bounded output stable system with a pole on right half S plane, and second statement is telling there is no causal unstable system with a pole on right half S plane. So first thing is, if a system is stable and causal, if a system is causal and stable, then the compulsory condition is, or this is going to happen if and only if all poles lie on left half of S plane, isn't it? So you must be knowing that for causality the ROC should be right of the rightmost pole, and stability the ROC should include j omega axis. So if you want to satisfy both causality and stability, that is ROC should include j omega axis and the ROC should be right of the rightmost pole, then obviously it makes sense in that case all poles should lie on the left of S plane, then only that is going to happen. Okay, so this is the condition for a system to be both causal and stable, all poles should lie on left of S plane. So coming to statement number 2, there is no causal and stable system with a pole on right half S plane. So this is representing a true statement. So it is telling there is no causal and stable system with a pole on right half S plane. In other words, if a pole exists in the right half S plane, the system is not causal and stable. So the meaning of this statement is, if a pole exists on the right half S plane, then the system will not be causal and stable. That is what we are telling. So it makes sense. The statement 2 is correct. What about statement 1? Statement 1 is telling there is no BIBO stable system with a pole on right half of S plane. Now to answer this, what we can do is, let us say I have a transfer function h of s which is 1 by s plus 2. Okay. Now where the pole will lie? The pole will lie on minus 2. This is the pole. Now if I ask you, okay, how many inverse Laplace are possible? You have two possible inverse Laplace. One of the possible inverse Laplace is, you'll have the, okay, so I have taken this example which pole is minus 2. So let us take the pole is lying on 2, s minus 2, because here the question is with respect to pole on right half s plane. So let us take a pole on the right half s plane. So if I take the transfer function 1 by s minus 2, so where the pole will lie? So the pole will lie on 2. So if I ask you, if the pole will lie on 2, so how many ROC are possible, or how many inverse Laplace are possible? So you'll have two possibility. One of the possibility will be something like this. So you may think of like this. So one of the possibility is this one. This is one of the ROC. And the other possibility is, if this is what is the pole, the other possibility is right of this pole, which is 2, like this. So here it is sigma less than 2, and here it is sigma greater than 2. So if somebody take, this is what the corresponding inverse Laplace, then in this case the ROC including the j omega axis. So this ROC is representing a stable system, but in this case ROC is not including the j omega axis, so this is representing unstable systems. So what is being happening? Even if a transfer function having one pole lying on the right of s plane, still the system can be stable. It is not necessary that it has to be unstable always. It can be stable, that depends what particular ROC we are selecting. Suppose if I ask you to find the inverse Laplace of this, so what do you get? So h of t, this is the left sided Laplace, we should take it. So in that case it will be minus of e raised to power 2t into u of minus t. You will get this. But in this case if I ask you what is the inverse Laplace, so it will be e raised to power 2t into ut. And I believe in the continuous time LTS system time domain analysis, you must have learned that the condition for stability of LTS system is its impulse response should be absolutely integrable. So this equation should definitely satisfy these conditions. So now if I ask you to plot this e raised to power 2t ut, so how does this will look like? So this will look like this. It's a growing exponential. And if I ask you whether this condition being satisfied by this or not, obviously not, because we are expecting it should be integrable, or the total area should be finite, because it's an unbounded graph which total area is infinite. So obviously whatever the prediction we made, it's unstable system, it is still unstable system. But if somebody plot this, how does this will look like? So actually how to plot this? If I ask you to plot e raised to power minus 2t ut, so how does this will look like? So this function look like this. Now if I am saying that you do the time reversal to this, if you do time reversal to this, that is if you are replacing t by minus t, so you will be getting it is e raised to power 2t into u of minus t. So in that case if you do time reversal, the corresponding waveform will look something like this. But my h of t is, so this along with a negative sign. So if I ask you to plot this functions, so this function will look something like this. So this is the waveform of h of t into h of t, which is nothing but equals to minus of 2 into minus of e raised to power minus of 2t into u of t. So obviously again this graph is a bounded graph, and anyway if you take the magnitude of it, so you will be again getting this function, because this is negatively positive, so you will get it. And if you again integrate this is again a bounded graph. So in this case it will be stable in nature, and that is what we predicted. So anyway if the Laplace ROC including the j omega axis, it should be stable, and again from the time domain point of view also it is coming stable. So statement 1 is definitely wrong. What it says there is no BIBO stable system with a pole on right half s plane. But what we have shown, even if a system having a pole on the right half s plane, still the system can be stable. So obviously this is contradicting statement 1. So statement 1 is wrong and statement 2 is true. And if you see all the options, option D where it is given that statement 2 is true, and option D is the right answer for this question.